In this video, we're going to do the second exercise on this worksheet, exercises on consumer and producer surplus. So let's scroll down to the second exercise here. So the question was to find the consumer surplus and the producer surplus at equilibrium. And so for these kind of situations, the first thing that we need to do is find the point of equilibrium. And the way we're going to do that is by finding the intersection of the demand curve and the supply curve. So let's go ahead and sketch both of those first to have a graphical representation of what we're talking about. The demand curve is a decreasing curve. It's a decreasing rational. If we look at the intercept here on the price axis, the intercept is when x equals 0, so we're going to have 24. And we're going to see if we imagine x going to infinity, there's going to be a horizontal asymptote going down towards 0. So here is our demand curve, which is 24 over 1 plus x. The supply curve is 2x, so s of x is 2x, and then we've got some sort of point of intersection here that is going to be our equilibrium point. So the x value of equilibrium is there, the y value, it is a price, the p value of equilibrium is there, and we're going to find those by setting the demand curve and the supply curve equal to each other. So 24 over 1 plus x is equal to 2x. I'm going to multiply up. So 24 is 2x times 1 plus x. Let's take the opportunity to simplify right away. So I get 12 is equal to x plus x squared, and if I move everything over to one side, x squared plus x minus 12 equals 0. We're going to factor this. This factors into x plus 4, x minus 3. So two solutions to the quadratic. X is equal to minus 4, and x is equal to 3, so we want the positive one for our region. And so this is the x value at equilibrium. The price at equilibrium is 2 times x. I'm plugging it into the supply curve. So 2 times 3 is 6. You could plug it into either curve and you should get the same answer. So our price at equilibrium is, our quantity at equilibrium is 3. Our price at equilibrium is 6. So we're going to find the consumer surplus first. The consumer surplus is interpreted as an area, the area of the region that is between the price at equilibrium on the bottom and the demand curve on the top. And so our consumer surplus is evaluated as an integral. So the integral from 0 to the equilibrium price of the demand curve minus the equilibrium price, and filling in the values that we know. So from 0 to 3, our demand curve is 24 over 1 plus x minus our equilibrium price is 6 dx, and so we can split up this into two integrals. So 24 times the integral from 0 to 3 of 1 over 1 plus x dx minus the integral from 0 to 3 of 6 dx. The second one is going to be very easy. The first one is not difficult at all. We can do a little u substitution. So let's let u equal 1 plus x. Du is going to be equal to dx. If I am paying attention, I realize I have to change my bounds of integration. So when x is 0, x plus 1, which is the u value, is 1. And when x is 3, u is 4. And this becomes the integral from 1 to 4 of 1 over u du minus, and then this one we can anti-differentiate right away. So the integral is 6x, the antiderivative is 6x, evaluated from 0 to 3. So this integral here, we're going to need 24. Antiderivative is going to be ln of u from 1 to 4 minus, and this we can go ahead and evaluate, 6 times 3 minus 6 times 0. This is going to be 24 times ln 4 minus ln 1 minus 18. Ln 1 is 0, and so our final answer for the consumer surplus is 24 ln 4 minus 18, and this is in either dollars or thousands of dollars or some sort of monetary value. So dollars or other monetary units. Okay, I haven't left myself a whole lot of room here, so let's carve out some space for the producer surplus. The producer surplus is also interpreted as an area. It's the area of the region below the equilibrium price and above the supply curve. So the producer surplus integral from 0 to the equilibrium x value. Again, this time the top is the price, the equilibrium price. The bottom curve is the supply curve, dx. So filling in these values that we know, again, 0 to 3 of the top curve is 6 minus the supply curve is 2x. Again, like we did in the last example, we could integrate this, but it's just as easy, if not easier, to recognize that our region is a triangle. And so we're going to do 1/2 the base times the height to find the area of that region. 1/2 of the base is 3, times the height is 6, and so 1/2 of 3 times 6 is 3 times 3 is 9, and then again, whatever monetary units apply to the problem, there's none given here, but this is some sort of monetary value.